This is not right. 3 T2. This is 340. This is minus 40, 380. Okay, it's a good way to check. So let's see now if it's okay. T1 is 380. So it's 400 here, 380 there. So it's really 20 here. 20 really equals to 10 times 2 in that direction. If we were to use this direction, so it's minus 20 equals to 10 times minus 2. It will also work. Let's go see if it works here. 380 here. We said 340 here. That minus that is really 40. 40 really equals to 20 times 2 in that direction. This one is 340. This is 300. 340 minus 300 is 40 up. 40 up really equals to 20 times 2 in that direction. We could have solved it as a whole, look at the system as a 1. So all the external forces in that direction are 400, assuming, okay, let's still assume that this is the direction. If this is our motion direction, so we go to this direction. We say all the external forces in this direction, which are 300, minus all the external forces in that direction, which is 400, must be equal to the mass of the system, which is 20, 20, 10, 50, times A. And A will be also minus 2. Again, the same result, but the disadvantage of this method is that if I now want the tensions, I must write these equations, at least 2 of them. So it won't be enough. But it's good to know that you can look at the picture as a whole. Okay, that was 8. Okay, one more. 90. Let's say I have a situation that you know from daily life. Let's say I have a truck. Okay, no wheels, a truck, which has a velocity here, it doesn't matter which, and no, I don't want to use friction yet, no, let's do another one. The friction will be next lesson, so more complex. Okay, this is M1, I pull it down by F equals to, I don't know, this is M2, I pull it, okay, like that, and M1, let's do it with the letters now, okay, this is M, this is 3 M's, and I want to ask, and the solution, when we write the solution, we are allowed to use M, G, and G. We are not allowed to use any other letters. And the questions are these. First question, what is F if we know that this system is remains in its state, which means A is 0. Remains in its state, also I remind you, it doesn't mean that it is in rest mode, it means that or rest or same velocity. It doesn't matter. So, how do I calculate it? First of all, no matter what they ask, forces. Downwards. If I'm talking with letters, don't put 10, just write G. So this will be 3mg, this will be T, this will be T, and this will be mg. If we know that this system is balanced, we say, or equilibrium state, no acceleration, if we look each mass separately, every force must cancel the other forces. So if we look at this one, we know that T must be equal to 3mg. And if we look here, we know that T also must be equal to mg plus F. that must cancel that, and that must cancel that. And if we, okay, we can, let's solve it. We can subtract them, we can, it doesn't matter what we do. Let's put this here, and mg plus f equals to 3mg, f equals to 2mg. Okay, this is our first example. Second example. Let's say f equals to we know 2mg is a very important thing for us to know, because what happens if I apply a little less force? It means that the system will accelerate that direction. And if I apply more force, it will accelerate that direction. So this force is really very important for us to know which way which direction this system will go, just by knowing if I put a little more or a little less. So let's do both. Let's put 5mg. If f is 5mg, I want to know what is the acceleration. So how do I do it? Now that I know that it's more than that, I know that it will accelerate that direction. That direction. So let's do Newton's law. Let's start with this mass. All the forces in this direction, which are F, which is 5mg plus mg, that plus that minus t, that plus that minus that, all the forces in the direction minus all the forces against, must be equal to the mass multiplied by the acceleration. This is this object. Let's go to that one. We know it accelerates up, so all the forces up, which are t, minus all the forces which are down, which are 3mg, must be equal to the mass, which is 3m, times the acceleration. Let's add them up. 5, 6 minus 3, 3mg equals to 4ma, a equals 2, m and m go, 3g, 3/4 g. And we don't write 10, 3/4 of 10, we just leave it like that, because the answer must be given with g or m. Okay, so now we know the acceleration. If we want to know the tensions, just put, instead of a, 3/4 g, and find the t. Okay, third example. What will be f is 1mg. What will be the acceleration now? Now, if I know that f is 1mg, less than that one, this one is for balance, the same state, or same velocity, or rest. If I put a little less, it means that the direction now will be this. This will be the direction of acceleration. And again, I remind you, even if you are wrong and you will do this direction, you will get a result with minus. Minus means that you got it wrong and the direction is that one. So the acceleration will be on the other direction. So we know, so let's solve it. Let's start with this one. We know it accelerates up now. So t minus these two are mg plus mg. F is mg plus mg, it's 2mg, equals to the mass, which is a, multiplies by a. Let's go to this one. This one accelerates now downwards. So this one is bigger than that one. So 3mg minus t equals to 3m multiplied by a to the mass times the acceleration. And if we add them up, t and t go, minus 2mg plus 3mg is 1mg equals to 4ma. We divide it by 4m, m goes, so a equals to g over 4. Obviously that direction. And we got a positive value, which means that we got the direction right. If we want the tension, again, just place g over 4 here and find the tension. If we were to look at this system as a mass, as a whole mass, we would say 3 mg minus the external force, which are 2 mg, 1 mg, and 1 mg is 2 mg, equals to the mass of the system, which is 4m, times A. So we get exactly the same result. mg equals to 4ma, A equals to g over 4. One more thing, when we're dealing with letters, don't use units. Just leave it like that. One more thing on this system, if I want to ask you what is the tension, let's go to this third, okay? In the third problem, we knew that F was mg. We found the acceleration g over 4. Let's find the tension also. I want the tension. The tension is, I need to calculate it, and I don't like these calculations, but still, okay, let's find it here, from here. T, from here, let's say, 3 mg minus T equal to 3m g over 4. Instead of A, I wrote g over 4. So T must be equal to 3 mg minus 3 mg over 4. T equals to, and again I want to show you something. When you deal with these kind of calculations, don't start to do common 4 and everything. Just look at the coefficients. 3 minus 3/4. 3 minus 3/4 is 2 1/4, and just add the mg. This is the way to find without doing the whole routine, calculation routines. Okay, just use the coefficient, that minus that, and add the mg. Okay, now suppose I want to find this tension, the tension on this rope. And again, I say that this pulley is massless. Massless means that the mass, we can neglect it. So I must apply forces on the pulley. Again, if you're not asked to do so, don't do so. But if you are asked, do it. So this rope will pull it downwards. This rope will pull it downwards. This rope will pull it upwards. Let's call it T1. These are the forces on the pulley. And I want to know this one. So this one will be according to the first law, because the pulley doesn't go up nor down. It stays in it remains in its state. So T1 must be equal to T plus T, 2T. So T1 must be equal to 2 times 2 1/4 mg. So T1 must be equal to 4.5 mg. So this is the way to deal with this rope if I am asked to do so. One more thing, pay attention that this tension changes if I change the F. Why? Because if I change the F, the acceleration will change. The acceleration will change, this tension will change. This tension will change, this will adapt to them. It will always be this one equals that and that, because it always remains in its state. So it will adjust according to the T. Okay. One last thing, very, very small, just to show you something that we said before. It is obvious. Now you can know why. Then let's look at the mass when I drop it, when it's in the air. When it's in the air, let's say the mass is m. What forces apply on this mass? Suppose no friction, no wind friction, nothing. Just mg. And we know, when I drop it, I know it accelerates, and we said that it accelerates by g. Now we know why, because the second law says that we know it accelerates here, downwards, so we say all the forces down minus all the forces up, which are 0 in this case, must be equal to the mass multiplied by A. We cancel the m, so we get A equals to g. So it works with this kind of problem also, of course, but just to show you where it comes from. Okay, so now that we know to find accelerations, tensions, with our 3 basic forces, normal force, tension force, gravitational force, what we'll do next, the other lessons, we'll start dealing with friction also, because it's a daily thing that we use. And we'll also deal with slopes later on. So you have a lot of things to expect in our next lesson.